Hello, Sam here. Let's do another Leetcode daily question. I do number 2441. Largest positive integer that exists with its negative. Let's start the timer and see what we can do. So we're given an integer array nums, doesn't contain any zeros, that's nice. Find the largest positive integer k, such that negative k also exists in the array. Return the positive integer k, so we don't even need the index, we just need that value, and otherwise return -1. So here we have a range where -3 and 3 is the biggest, so that'll return 3. Here we have 7 and -7 is the biggest, so we return 7. And here we don't have anything, so we return -1. Some of the constraints, since this is Leetcode, everything fits in memory. In fact, all the values fit in big int or int space. Never going to be bigger than 1,000, -1,000, never be 0. So let's think about how we want to solve this. Kind of what I'm thinking about is first, what's the ideal case? It's always going to be O of n time. You have to look at every single value in the array, and you're returning just the index, so in a perfect world it'll be O of 1 space. And I think the way you might be able to do that O of 1 space is very brute force. Check every pair of ints, every pair of values. If positive, negative pair, check if better than best, replace if so, and then finally return best pair or -1. Well, not return best pair, pair positive value. This is very, very slow because you're comparing every single pair, so that's O of n squared time. And O of 1 space is the one nice positive for that. We're probably not going to do that. Another approach is dictionary based, hash map basically. And the idea here is first pass, get all negatives and keep in dict. Second pass, check positives only if has negative pair. This is a O of 1 check. Do the same thing as the brute force, keep best and return best positive. So in fact, what we can do is, I'm trying to see if we could do this all in one pass. There's not really too much of a value in that. We're still O of n time. This is going to be O of n space, worst case n over 2. Could we do anything? Let's see, approach 3 mathy. Could we do any sort of like sum of the values? Could we sort the array? We could sort the array. Start from outside, 2 pointers, start from outside going in to find pairs. This is kind of interesting. It would be O, let's say for quicksort, n log n to sort. And if it was in place, O of 1 space, but you've modified the original array, which usually is a pretty big no-no in programming world, but is an option when you're considering an algorithm. This is better than the brute force and keeps the O of 1 space. I think approach 2 is what we're going to end up with. I can't think of anything mathy yet. You could try to keep track of every positive integer and then look for its negative complement, negative pair basically, while you're going through the array. Some sort of like min heap thing, perhaps. The only thing I could see here being is O of n time and some sort of O of, it's not going to be log n. I'd love a log n space solution. Can't think of this. If you can think of it in the comments, please let me know. Otherwise, let's just go ahead with approach number 2, building a dictionary and going through the array. So let's say positive is equal to an empty dict and negative is equal to an empty dict. And then for val in, what's it called? Nums. If val greater than 0 equals true, O of n time and space usage. We definitely build up the O of n for both. If you have repeats, it doesn't really matter. And then you can just do a check through the items. Best equals, let's call it 0 to start, since we know it's, or actually we'll call it -1 to start. For val in positive val, if the negative val of that is inside negative, then val is greater than best, then best equals positive val, and at the very end we return the best. So this will be, you know, worst case O of n as well. All these checks for inside of a dictionary is amortize O of 1. Technically you don't need to even build this second array. We'll get to that in a second, but this is kind of one approach. What happens if the length of the array is empty? Both of these will be empty dicts, nothing will happen, best -1. Should be okay. All right, let's try running this and see what we get. Wrong answer. Oh, whoops, I'm supposed to return the value, not the keys, not values. That's a mistake. Sorry about that typo. We don't want the actual true or false. Yep, all right, it did run, and all of these cases are accepted. Let's do a submit and see how we did. And it was accepted, and we're inside the bell curve, not one of the fastest. I wonder what the optimizations are, but good to see. Let's think about this for a second and see how we could slightly improve this. So we don't want a positive dictionary, and what we're going to do is build a negative dictionary if val is less than 0, and val for val. And then finally, we can now just check for val in nums. If val is less than 0, continue. Otherwise, we check. Can we make this a little smaller? Should be a way to use the generator. Yeah, there we go. Let's submit and see if that changed anything. Yep, a little bit faster now. That's good to see. Let's think about any other optimizations we could do here. I would like to turn this into a one-liner. So how could we do that? If val less than 0 and negative val, and then we'll just return the max of that. And -1 if it's an empty array. Oh, right. It's greater than 0 and the negative is in negative. There we go. Okay, let's try submitting this. And it's a little bit faster. Good to see. These are some minor optimizations I could see us doing. This is kind of beyond the scope of this problem. I think this was a pretty fun one otherwise. Hope this was interesting to y'all watching. See y'all next time. Cheers.